This is your geometry worksheet. That stuff that I told you about the ratios, the distance or the ratio of the chord to the diameter equals the ratio of the distance to the whole thing there. No, it doesn't work. Forget about that. I was just testing you. That's it. Testing you. And you failed the test. Actually, no, I just had it wrong. Hey, everyone makes mistakes. All right, so I'll show you the right way to do these as we go along. This says AB is 15. Forget about that ratio stuff. That means AD is 15. That means AC is 15. And it says CD is 24, and it's cut in half by this perpendicular radius. That means DE and EC are each half of CD. So this is 12. This is 12. And then two ways to find AE. We have this little triangle here with a 12. One leg is 12. The hypotenuse is 15. We can use Pythagoras. AE squared plus 12 squared, which is 144, equals 15 squared. What is 15 squared? 225. I just happen to have it there. 225. And then AE squared equals 225 minus 144 is 81. And then AE equals 9. Now you could have gotten that without using the Pythagorean theorem. You could have used memorized Pythagorean triples. 3, 4, 5, 5, 12, 13 are two common ones. You can look up many, many more and memorize all of them, but they're all multiples thereof. So you can have a 30, 40, 50 right triangle. Multiply a 3, 4, 5, everything by 10. Well, look, 15 is 5 times 3. 12 is 4 times 3. So AE would be 3 times 3, which is 9. It's a 3, 4, 5 triangle multiplied by 3. But the bottom line is AE actually equals, I forgot to write in that, set the square root of 81, whatever. The bottom line is AE is 9. If you had your Pythagorean triples memorized, you'd get the same thing. All right, let's look at this one. Number 2. Excuse me. DC is 16. AC is 20. Find BC. We have to find that piece. Okay, if we can find AD, we could find AB because they're both radii, and then subtract AB from 20, and that will give us BC. I think you've done that. You've used the Pythagorean theorem. 16 squared plus B squared, we're calling this B, equals 20 squared, and then 256 plus B squared equals 400. B squared equals 144. B is 12, and then BC equals 8. So if B is 12, and if you want to show all your work, BC equals 20, which is CA, minus 12, which is AB, equals 8. So there you go. Okay. Next. Again, you've got some things already written in, and I believe you have it right. AB is 5. Yes. DC is 5. Yes. Find BC. That's this. If AB is 5, that's a radius. AD is also radius 5. That makes this whole side 10. And by Pythagorean Pythagorean theorem, 5 squared plus BC squared, or you could call it x squared, whatever, equals 10 squared. BC squared equals 75. Well, you have it. You have it right here. And then 5 square root of 3. So that one, you've done right. Number 4, that's the one where I started talking about these ratios. Let's see if I can redraw this or something. BF, that's this whole thing, is 24. Okay. Oh, okay, that makes AC 12 because it's a radius. The diameter is 24, AC is 12, AD is 12, CD is 16. That makes each one of these 8. I don't know what this letter is here. E. CE is 8, and DE is 8. Find AE. So we have a triangle that looks like this. 12, 8, and then this is AE, and the right angle is here. Mine doesn't look like it, but it does. So AE squared, forget about this part over whole stuff. That was wrong. AE squared plus 8 squared equals 144. And I just wrote the triangle here because this is supposed to be the right angle. Oh boy, let me start this again. Let me draw this again. I drew it outside because it's a mess inside there. That looks more like it. And this is A, E, C. And AC was 12 because if BF is 24, then the radius, which is AC, is half of that, which is 12. And then CD is 16, which makes CE half of that, which is 8, because it's cut in half by a radius. So that's where we get AE squared. I had to redraw it. Plus 8 squared, which is 64, equals 12 squared, which is 144. I don't know if that's a Pythagorean triple. You might look them up and see if it is, because it'd be quicker that way. Your teacher might want to see work, though. So what is 64? That would be 56. Well, AE squared, for some reason my brain isn't working, equals 144 minus 64 is 80. AE squared equals 80. And then AE equals the square root of 80, which is 16 times 5. Yes. And 16 is a perfect square, so it's 4 square root of 5. We pull that out. This stuff is wrong. That ratio stuff I told you about, incorrect. This is 4 square root of 5 is what AE should be. So there is our answer. All right, number 5. AE equals 8. You've already drawn it. Well, let's see if you did this right. AB is 17, and they want BE. No, find BD. Well, BD is going to be twice BE, and BE comes out to 15. You did 8 squared plus x squared equals 17 squared. Yeah, that looks good. And then x squared equals 289 minus 64 is 225. X is 15, BD is 30. That is correct. You are correct. I've lost sight of my little arrow here. Okay, this one. Excuse me. I believe you have this one right, number 6. These are two tangents that both go to the same point, so the two tangents are equal. 8x plus 3 equals 10x minus 7. And then 2x equals 10, x equals 5. You got it. All right, onward and upward. AB equals 4. AB equals 4. CD equals 6. Excuse me. Find BC. Well, if AB equals 4, then AD also equals 4. I think I can show you two ways to do this one, and we're trying to find BC. BC is a leg of a right triangle, Pythagoras. We could use BC squared plus 16. That's 4 squared equals 6 plus 4 squared, which is 10 squared, which is 100. And then BC squared equals 100 minus 16, which is 84. And BC equals square roots 84, which is equal to, then you have to see if you can find perfect square factors. I'll just divide by 2, is 42, 2, and 21, and 3 times 7. So the 2 can come out, 2 2's. When I take it out of the square root, I end up with 1, 2, 2, square root 21. All right, the other way to do it is a formula that we'll use later on. And this formula says this. When you have a tangent segment like this that goes out to an external point, then we can take that squared, BC squared. And then that's going to equal this outside part, which is CD, which is 6 in this case, times this whole segment that's part of a secant. It's the chord plus the part outside the circle that goes to that exterior point. And we don't know, do we know what that equals? 6 and 4. Yeah, this is also 4. So 6 plus 4 plus 4, 8 and 6 is 14. So 6 times 14. So BC squared equals 84. And then BC equals square root of 84, which we found out was 2 square root 21. Okay, so again, It's this outside portion squared, or this segment that goes from the tangent point to the outside point. You square that, and then that equals this outside part times this whole thing. Okay, so we got that one, but we got 2 square root of 21 either way. BC equals 30. AC equals 34. Find BD. Well, this is a right angle. I think this is supposed to be a tangent point. I'll just draw it in. If it's not, then I'm wrong, but I think it is. And we can find AB now using Pythagorean theorem, and then we multiply it by 2 to find BD. So let's check it out. AB squared plus 900 equals 34 squared, which is 34 squared, which is 1156. And then AB squared equals 1156 minus 900, so it's 156, it's 256. Look at that. And then AB equals the square roots of 256. And what is that, 16? I think it is. Yep. So equals 16. So if AB equals 16, BD equals 32. Now, BD equals 32. I want to look up these Pythagorean triples and see if might be worthwhile to memorize this list because it should be there. Well, I guess it's not. The one we just looked at, 32, 30, 32, 34, not in our list of Pythagorean triples, but it is nevertheless. Well, wait a minute. Remember, we can divide. So this would be divided by 2 is 16, 15, 17. Is 15, 16, 17 a Pythagorean triple? Well, it's not. What is going on here? Well, it's not. I thought it would be in there. I really do think. Let's double check it. AB squared plus 900 equals 34 squared. 34 squared is, I thought it would be in our list of Pythagorean triple, 1156, 900, 1000, 1100 is 200 plus 56. AB equals square root of 256 is 16. BD is 32. Oh, wait a minute. Wait a minute. Wait just a minute. The whole thing is 32. This is a 16. So it's a 16, 30, 34. If I divide those by 2, it's an 8, 15, 17. Is 8, 15, 17 a Pythagorean triple? Yes, it is. Right here, 8, 15, 17. So I was dividing the whole thing, BD, which is the diameter, but AB is only the radius. But anyway, Pythagorean triple. Pythagorean theorem gave you your answer, or if you memorize the Pythagorean triples, you get it very fast. Although if your teacher wants to see the work, maybe you could just write Pythagorean triple. AB equals 4x plus 12. BC equals 6x minus 4. I'm not even going to go further on this one. When you have two tangents that go out to the same point, those line segments are going to be equal. So set those two things equal to each other and solve for x. And that's it for sheet 1. I will not save any of those changes, and then we'll go to sheet 2. DF. Okay, we've written things in here again. DF equals 20. That means that the radius, DF is a diameter, so the radius is 10, and the radius is 10. AB equals 16. We have a radius that cuts that chord that is perpendicular to that chord, so it cuts it in two. That means each one of these is 8. AE is 8 and EB is 8. Find AE. AE equals 8. Okay, number 11. AB is 10. Find CD. Now you're going to have to tell me, send me an email. because if these two lines that show that segment, I don't know whatever that point is, but this segment equals this segment, if those are things you added, then we have to go about this question a different way, this problem. But if it's something that was already written there, then we do it like this. And that's how I'm going to proceed. So number 11, you've got to let me know if you drew those things in. Because if you did, maybe they're not true and we have to look at something else. So AB is 10. That makes this 10 and this 10. And then that makes each of these 5. And it says find CD. Well, this is again, whatever this point is, A, B, C, D, call it point E. So CE squared plus 5 squared equals 10 squared. And then once we find that, we can find CE. And if we have CE, then multiply it by 2 to get CD. So CE squared equals 10 squared minus 5 squared is 75. CE equals square roots 75, which is 3 times 25, which is 5 square root of 3. And then CD equals 2 times 5 square root of 3 equals 10 square root of 3. Now again, I don't know. That's only if these two segments are an equal length. And I don't know if you wrote that in or it already had that. If you wrote it in, send me an email and I'll have to look for a different way to solve this. All right, AB equals 8. BC is 12. Find AC. Find AC. Well, that's the Pythagorean theorem. 8 squared, which is 64, plus 144 equals AC squared. And 64 plus 144 is 8, 10, 208. And so AC equals a square root of 208. And we want to try to find perfect square factors, so I'll just start taking 2's out. 2 times 104, 2 times 52, 2 times 26, and 26 is 2 times 13. So I have 2, 2, 2, 2. That's 16. The square root of 16 is 4. 4 square roots 13, and that's AC. Okay, what is 4 times square root of 13? 4 times square root 13 is 14.4. So I just wanted to make sure it was bigger than 12, which it is. All right, so that's how you get that one. Thank you. What's next? Did I find the right thing there? AC. Yes, I did. Okay, next one. We're trying to do all of these. Next one. BC is 24, and since this is cut by a radius, then this is 12, and this is 12. FD is 26. That means the radius is 13. 13. And it wants you to find AE. Well, if you had memorized your Pythagorean triples, just the two basic ones, 5, 12, 13 is a Pythagorean triple. You could also use the Pythagorean theorem, AE squared plus 12 squared, which is 144, equals 13 squared, which is 169. And you can finish that, or, and again, I don't know, if your teacher wants to see work, I don't know what you'd write there. By the Pythagorean triple, 5, 12, 13, AE is 5. So let's look at number 14. BC is 12. DC is 6. Find AB. My goodness. Okay, I think we're going to use this one again. There might be another way to do this, but I can only think of it this way. Remember, BC, this segment here, squared, 12 squared, equals this outside segment, 6 times this whole thing. And that's going to be A, B, C, D. We'll call this E. So times CE. Now, once we have this whole thing, CE, we can subtract 6 from it, get the diameter, and then divide that by 2, and that will be the same as AB. So this is 144 divided by 6 equals CE equals 144 divided by 6. If you do it on your calculator, is 24. So CE is 24. CD is 6. 24 minus 6 is 18. Each one of these is 9. That makes AB 9. Okay, very nice. Nicely done. And let's just double check it. AD is 9. DC is 6. 9 and 6 is 15. So 9, 12, 15. That's a 3, 4, 5 Pythagorean triple, right triangle, all multiplied by 3. So just kind of verifies it. So AB equals 9. Got it. Thank you. AB equals 5x plus 2. Yes, it does. BC equals 8x minus 4. Since those are two tangents of the circle, both going out to the same point, those are equal. AD is 5. It wants us to find BD. Well, once we find what x is, we'll know what BA is or AB is, and then that's a right triangle there. So AB squared plus AD squared equals BD squared. So 8x minus 4 equals 5x minus 12. 3x equals 8x minus 4, 5x plus 2. Sorry. I knew I did something wrong because something didn't look right. This is 5x plus 2, not 5x minus 12. So 8x minus 5 is 3x equals, and it's not plus 12, is it? 5x plus 2. Where am I getting? I'm just making things up. Wait a minute. I'm just making things up. What was all that? 8x minus 4 equals 5x plus 2. So 3x equals 6. X equal to, if x is equal to, 5 times 2 is 10 plus 2 is 12. I think I was thinking about that, 12. So we have AD is 5, 5, 12. You can use a Pythagorean theorem, or I remember your Pythagorean triples, 13, and you'll find that BD is equal to 13. And again, if you're using your triple, I don't know. You can just write, I know my Pythagorean triples, 5, 12, 13. Or you can just use the Pythagorean theorem. All right, CB is 8. CD is 4. Find AB. All right, we're going to use that segment tangent thing again. BC, the tangent squared, equals the outside part here, 4, times this whole thing. So again, we'll call this E times CE. And then once we know CE, we can subtract 4 from it, and then we'll know the diameter. We'll divide that by 2, and then we'll have AB, which is the radius. So let's see. 64 divided by 4 equals 16 equals CE. If CE is 16, then ED is 16 minus 4 is 12, and that makes AB, the radius, is equal to 6. AB equals 6. And let's just double check that. If this is 12, then this whole thing is 10. 6 is the radius, plus 4 is 10. And let's see if that works. 64 plus 16 equals 100, which is 8 squared plus 6 squared equals 10 squared. All right, so AB equals 6. And that's our formula again. The formula again is when we have a tangent and we have a chord, even if it's a diameter, it's still a chord, and then it extends out on a line segment out to the same point. Then that tangent segment squared equals the outside times the whole thing. All right, let's look at 17. AB equals CD. So that means that these two things are equal. GE equals 5x. Thank you. And GF equals 3x plus 4. I'll try not to get this one wrong again. And find x. So 5x equals 3x plus 4. And that gives us 5x minus 3x is 2x equal 4. X equal 2. Bingo. Okay, next one. Is this the last one? Yes, it is. The last of us, the last of them. AB is x plus 7. BC is 5x minus 9. Find x. Well, again, since they're two tangents that go to the same point, they're equal. Set them equal to each other, solve for x. I'm not going to work the whole thing, but there's all those questions. So remember, that ratio thing I talked about, ditch it. It is incorrect, no good, get rid of it. I made a mistake. I go to the doghouse, get rid of it. If you need, if you have any questions on this or it was a little bit too fast, then rewind. Be kind, rewind, and watch them again. Watch them again. Put it in slow motion and watch it in slow motion if it's too fast. And again, I can't remember which number it is. Was it on this one? I think it was, oh no, yeah, it was on this one, number 11. If these two segments that are equal, if that's something you did, then you need to email me, franktutor@outlook.com, and let me know. And I have to find a different way to do number 11 because, again, I can't tell if that's what they have, if that's what they put in there, if that's what the people who made the problem put in there, then it has been worked the right way. If not, it might not be worked the right way, and I'm going to have to look up and find what theorem has to do with it. All right, that is it for your geometry worksheet this week.